Okay, 6:30. We are starting now our next meeting of the Advanced Programming Specialist Group. And as colleague noted that I have to introduce myself because today I am a speaker. The talk will be on R language or decision-making systems. What is R, why not R? I don't have much experience with R, but I was asked once to produce overview what is behind of this programming language, and that's what I trying to convey today. So abstract you can read yourself. It is basically was published on the announcement. So we will look at the typical things like hello world in different languages. Look at what is R, history of R, features of R as a language, implementations which exist, comparisons of R and Python for data sciences, then discussion of slow with some demo and conclusions. So a typical thing to do is when you have a system, you have a prompt, you put variable myString with content in brackets, print myString, and that's what you get with numbered line. Or if you save it the same to the test.r, the text is there, and then you do R script test.r, it gets exactly the same result. So, R is a system for statistical computation and graphics, which reminds immediately some other system which is existing for many, many years, like Excel. It consists of R language. Language behind of Excel is some visual basic macros, which allows you to do flexibility in behind of this scene. Plus runtime environment with graphics, which has also a debugger, and Excel has some also functions related to the debugging, and Excel has certain system functions, and the ability to run programs stored in script files. So as a language, it's an important tool for development in the numeric analysis and machine learning spaces. It's the most popular language used in the field of statistics. That is a quotation. It's very hot currently. By 2013, there were more than 4,400 add-on packages, 8,000 more members in the LinkedIn R group, and there are also 80 R meetup groups. It is free as a software. It's open source, it's powerful, and highly extensible environment which contains a lot of the pre-packaged stuff, which is pretty easy to use. As programmable environment, it uses command line scripting as a mechanism to store and reuse, which may bring a series of complex data analysis in various steps. This makes it easier for others to validate what is done with help of this kind of software, because steps are recorded, you know what is done, and research results can be then be rigorously checked for errors. And there was a known Excel coding error, which was among the several flaws found in influential economic analysis report known as Reinhard Rogoff. You can see the references at the end of the slides. And the reason is why that it was all hidden in the Excel environment, and it took a while to find out why results are actually as they are, because it was difficult to find out the mechanism of working. So that's why our enthusiasts are saying that make sure your work is reproducible. How to measure language popularity? There is a Tiobe programming community index, which can be found at this website. And you can check using this whether your programming skills are still up to date, meaning that what you know is in demand, or to make strategic decision about what programming language should be used for development of some particular system. Rating for December 2016, if we compare with 2015, that our language popularity moved to 17 from 18th place. For comparison, rating for C# was 6 down from 5, and PHP 7 down from 6, remained high but have dropped. So here is an example of the graph which Tiobe can produce to you. So that is what is showing that the highest position since 2001 was number 12 in May 2015. Lowest position since 2001 was number 73 in December 2008. So that's how variability of popularity can change. And for some date in July 2017, that is a different graph. So if you check today, that probably it's still having a trend of increasing with variable changes. So this is for August. So if we are comparing for such area what language to use, very often people say, okay, there is Python as well, which is also popular for data sciences, decision-making system and such. So popularity rankings for Python in years from 2013 to 2015 is roughly going down. And popularity of R is roughly going up. Here is another figures for two languages, for which place they occupy. And then there is data about average salary for high playing skills and experience. For R, 150,000, and for Python 94, which are comparably high. And another graph can be looked at there for comparison of the R versus Python. So then, what can be said against R? Why not R? It can be daunting to use it because syntax is different from that of many other languages. Language is actually fairly simple, but it is unconventional. Another argument that R is slow, which we'll discuss later on, slow meaning that has very powerful semantics and was developed to make the life of statisticians easier, which means we request what we need to do by simple commands, which require high calculations behind the scene. So it gives higher load to the processor. It may be also slow due to the poorly written code. So there are multiple packages to improve R's performance, such as PQR, RentGen, FastR, RIPOST, and many more. So a little bit now about history, how it was developed and why. So R as a language is dialect of S language, which preceded it in the time. There are some important differences, but much of the code written in S runs also on R. S was created by John Chambers at Bell Laboratories, where Unix was developed and C. S was initiated in 1976 as internal statistical environment, originally implemented as Fortran libraries. As you know, that Fortran was developed quite a significant libraries for in Fortran, where they developed significant libraries for various mathematical and engineering calculations. And one of the styles of coding for example, processing of the physical data in the Research Institute was that physicists were opening files with data, then using call to various standard procedures, and then either printing or saving the results. So this kind of style of programming, when using ready functions and then transferring them between these functions via just temporary variables to control the flow. So based on that was developed a language rather to control it, not to code in Fortran per se, but using Fortran libraries to use the same calculating environment. So there were no functions for statistical modeling in early S. So-called Blue Book introduced what is now known as S version 2, which was in '88 by Richard Becker, John Chambers, and Alan Wilkes, the new S language. In '88, it was rewritten in C rather than in Fortran as version 3. It is similar to current version of S. In '98, it released a version 4 of S and is used today. So R was created at the University of Auckland in New Zealand by Ross Ihaka and Robert Gentleman. That's why Ross and Robert R. The project was conceived in '92. Initial version released in '95. Stable beta version released in 2000. The folklore is that named it partly after the first names of the first two authors and partly as play of the name of S, like next after S, or close to S enough. Currently developed by the R development core team, which chaired, where John Chambers is also a member, the S originator. R is official part of the Free Software Foundation's GNU project with goals similar to the Apache Foundation of the GNOME Foundation. The features of R. It is for statistics. Dialect of S supported by graphics, combined with lexical scoping semantics inspired by Scheme language, which is dialect of Lisp, that stresses conceptual elegance and simplicity, allows branching and looping as well as modular programming using functions, and easily extendable through functions and packages. Statistical features and library implement classical statistical tests, classification, clustering, linear and nonlinear modeling, time series analysis, and other some which are based on the Fortran libraries. So it is producing graphs and helps to produce documentation. So static graphs can produce publication quality graphs, including mathematical symbols, and dynamic and interactive available through additional packages. Documentation online and maybe in hard copy as well. For using of RD format is known, it's a special LaTeX-based documentation format, which allows you to write a text, which is easy to produce then variously flexible documents from the same kind of source space, including where parts of the code can be included to support that, to document the process of statistical analysis, etc. So, principles of implementation. Due to its heritage related to the S language, R has stronger object-oriented programming facilities than most statistical computing languages, many of the R standard functions are written in R itself. So many languages use it so-called bootstrapping. So initial version written in some other language, but gradually replacing some components by parts which are written in the same language. But is it efficient way of implementing? That's one of the questions. For computationally intensive tasks, C or C# or C++ and Fortran code can be linked and called at runtime. Advanced users can write C, C++, Java, and .NET or Python code to manipulate objects directly. R is highly extensible through the use of the user-submitted packages for specific functions, which are needed in specific areas of study. Extending of R is also eased by the lexical scoping rules. So extension packages. R capabilities is achieved through user-created packages. Specialized packages, graphics-oriented packages, special devices can be added using ggplot2, import-export capabilities, reporting tools such as init-R, Swiv, etc. So developed primary in R itself sometimes could be done in Java, C, C++, and Fortran as well. More than 7,800 packages exist by January 2015 available. They are covering the comprehensive archive network called CRAN, where is also CRANtastic, RForge, Bioconductor, Omega Hat, GitHub, and other repositories. So there are so-called task views in CRAN, which are focusing for finance, genetics, it's one of the hot areas, high-performance computing, machine learning, medical imaging, social sciences, and spatial statistics. And R has been identified as suitable for the data analysis for clinical research. So Bioconductor project focusing on the analysis of the genomic data, such as Affymetrix project and cDNA. For coding in R, there is a number of various graphical user interfaces, such as Architects, which is cross-platform open source interactive development environment for data science based on Eclipse and StatIt. DataJoy, open editor focused on beginners to data science and collaboration, which unfortunately discontinued from 2017. Deducer is a graphical user interface for menu-driven data analysis, similar to SPSS, GMP, and Minitab. Java graphical user interface for R, or JJR, cross-platform stand-alone R terminal and editor based on Java. Number analytics is for R-based business analysis, similar to SPSS, working in the cloud. More of the interfaces is Rattle graphical user interface, cross-platform, which is based on the RG2, and specifically designed for data mining. R Commander, a cross-platform menu-driven interface based on TCL/TK. Several plugins to CMDR are also available. R GUI, which comes with pre-compiled version of R for Microsoft Windows. K-Word, extensible graphical user interface and IDE for R, and RStudio, which is cross-platform open source IDE, which can also be run on remote Linux server. So, special issue of Journal of Statistical Software discussing graphical user interfaces for R, which is in volume 49, 2012, which was special volume for graphical user interfaces for R. And this is very established journal, of statistical software, publishes articles, book reviews, etc., etc., etc. So it was attracting pretty significant attention after this inception. So editors and interactive development environments with some support for R exist as well, such as Atom, Context, Eclipse, Emos, which is very popular and very much easily to be transformed for support of various languages. JEdit, Kate, Lix, Notepad++, Sublime Text, TextMate, TinR, Vim, Visual Studio, WinEDT, etc. So scripting languages R functionally has been made accessible from several scripting languages such as F#, Julia, which considered as replacement for Java, Perl, Python, Ruby. So scripting AI itself is possible via a front end called Littler. Commercial implementations of R. Big Data Appliance by Oracle in October 2011 is integration of R, Apache, Hadoop, Oracle Linux, and NoSQL database with Exadata hardware. Oracle R Enterprise is one of two components of the Oracle Advanced Analytics option. The other component is Oracle Data Mining. In Hadoop, execution of R by IBM, providing programming model for massively parallel in-database analytics in R. Revolution R is distribution of R by Revolution Analytics from 2007. Includes components such as Parallel R, the R Productivity Environment IDE, RevaScale R for big data analysis, RevaDeploy, R web server framework, and the ability for reading and writing data in the SAS file format, as well as to comply with established criteria for the pharmaceutical sector. In 2015, Microsoft Corporation completed the acquisition of Revolution Analytics. So now the Microsoft R product family includes Microsoft R Server, Microsoft R Client, Microsoft R Open, and SQL Server R Services. Spotfire by TIBCO offers runtime version R. Valid R by Mango Solutions for organizations in highly regulated sectors. Complies with Food and Drug Administration guidelines. Other systems supporting integrating with R are Dundas, S3, ArcGIS, GMP, Mathematica, MATLAB, Platform Symphony, SAS, SPSS, Statistica, StatGraphics, and Tableau, which are all very known packages for statistics. Now, something about R flows, or let's say features. R is relatively weak in memory management. Efficiency depends on the problem, data set, and algorithms. Might be irrelevant, could be important for some particular implementation of the R analysis, or it could be disastrous if it's wrongly used. So some algorithms consume very large amounts of memory on very large data sets. Some operations cause objects to be copied rather than modified in place. So subtle changes can be optimizing significantly and have significant impact on the overall efficiency of the usage of memory. R has too many different ways of doing things. It's hard to figure out which one is the best for a given task. Some correct code may not work. There are known and published cases when code is correct, compiler is not complaining, but it doesn't work. This also contributes to our syntax being hard to remember. Our core team says guys who control our software development, they prefer statistical and mathematical robustness via backwards compatibility. to minor improvement in performance. So this is a tradition from the Fortran time, that all Fortran versions are backwards compatible to the Fortran 4, which is very valid standardization effort. So if we compare code which is written in R with code written in Python for the same type of things. So here is basically something what we want to do, some formula. And there is a code written in R, there is a code written in Python. It looks like Python is approximately 30% more wordy for the same kind of things. And here Gurobi is used as optimizer in solver for linear quadratically constrained and mixed integer programming problems. So next is to compare between R and Python, that for the R and for the Python, we may say that R is specialized. Picture says more than 1,000 of words. That's why a lot of graphics, so it's producing quality graphics. Visualization packages such as ggplot2, ggvis, Google Viz, and rchats. There is whole R ecosystem, which is packages and active community which supports it. R is lingua franca of data science, not necessarily computer science background to get started. Increasingly adopted outside of academia. And to compare that, for Python, it is there is IPython notebook, which helps to work with Python and data. It is general purpose language, relatively flat learning curve. Python testing framework is built in code quality. It is multi-purpose language, can easily be learned by statisticians, helps to integrate with every part of the workflow. And against of those languages is that, as mentioned before, R is slow, can be improved. R has steep learning curve, which is non-trivial, especially for graphic user-oriented statistical analysts who never done coding as such in any language. Finding and adopting suitable packages can be time-consuming. There are thousands of them. So which one will work for you? So Python is also known as being slow because it is interpreted language. Python is challenger to R, but non-alternative to the hundreds of essential R packages, because there are definitely things which doesn't exist in R, in Python yet. Now, discussion of slow, which affects both approaches. How to improve processing performance to solve more problems faster and save time and money. To solve larger and more realistic complex problems and reduce power consumption. So runtime is a function of the total CPU instructions in the code, cycle per instruction, and time of cycle. So if we look at the total CPU instructions, so it very much depends on the problem area or problem or data size overall, how volumes are what we want to process. So this relates basically to the algorithms, how efficient are algorithms which we are using, or whole the area of big data using special algorithms. Quality of machine code, which relates to the weight of the code which is on board. How much binary code is produced as a result or involved as a result of our original coding. Quality also depends on what programming language you use, which depends on the problem. If we choose some particular language, It automatically relates to the problems which it's solving. Quality of the programming environment, which could be too many factors which are affected. Quality of translator or compiler, interpreter or optimizer, which is involved in the process of producing of the final running code. Other tools, editors or application program interfaces which are employed. And then obviously quality of the source code, which is very subjective in many cases, how you assess it. The same task can be implemented in different way. And then, of course, quality of the programmer. And usual understanding is that programming is as a process is not a science, but more kind of craft. Depends on the experience. I remember reading introduction to some computer science book. There was quoted anecdote that the violinist Yehuda Benuchin is working somewhere in New York, and some stranger comes to him and asking him, "Excuse me, what is the way to Carnegie Hall?" "Oh, it's practice, my dear." That is very much relates to the programming. Practice and education, of course. Quality of programming environment, again, depends on how you assess it, how you use it, if you know how to use it correctly, etc. Then next factor is cycles per instructions, which depends on the architecture and technology. It could be Intel, AMD, ARM processors. It could be CISC processors, it could be RISC processors. NVIDIA recently come to the picture as a producer of the calculation type of environments, which originally was for graphical processing only. Time of cycle, it also depends, of course, on CPU architecture and technology, and also varies in all those implementations. So overview of the transistor on chips. In 50s, it was one transistor. Sorry. Okay, I don't know what happened. In 60s, it was 16 transistors on the same chip. 70s, 4,500 transistors. 80s, 275,000 transistors. In 90s, 3 million transistors. In this century is already half a billion transistors on the chip. With more transistors, we have deeper instruction pipelining, a superscalar processor. Implements more complicated instructions, more operations per time period. Transistor clock speed depends on the frequency and rate of how it runs. How fast it's switching between on and off in the transistor, defines speed of the operation. With a smaller transistor, we have shorter critical path, quicker capacitor charging, discharging, and it resulted we have faster clock implementations. So the electrons have to travel certain way. So the path, physical path, is really important. How what is the distances involved there. So transistor size is important here as well, but there is a limit. By now, some people say that Moore's law is dead, or is it not? Intel's 3 years lead was recently that how new technology very actually implemented after first introducing, which was required about 3 years to get to the mass production for various sizes of the chip precision technology. So how small transistor can be? For Intel 4004 microchips, it was 10,000 nanometers, which followed by 88 Intel 3,000 nanometers. 386 was already 1 1000, etc. We're reducing with Intel Core i7 32 nanometers. And then next steps we're attempting to do even less, and then we're coming to the size of one phosphorus atom, which is 0.1 nanometer. This is probably absolute limit which we maybe achieve by 2022. So whatever happens, there will be a limit. So power consumption depends on capacitance, square of voltage, and clock frequency. Increasing of the frequency requires increasing of the voltage for given transistor size. So it is function of the square of the frequency. Gaming PCs are now equipped by the water cooling systems, which is pretty significant indication of how much heating is produced there. Data centers are placed in the areas with cold climate because of the same obvious reasons. So we have here indication of where the power density in watts per square centimeter lies. On the sun surface, it's 10,000 of the watts per square centimeters. And a rocket nozzle, which is launched from the surface of the Earth, it's about 1,000. A nuclear reactor is 100. On the hot plate is somewhere about 10. And then Pentium line processors of 46 are somewhere in the middle here. Here was development from original Intel processors with significantly increasing and then improving by middle of 80s. From the 386 processors, it was better than previous ones, but still the computing power required to increase power density per square centimeter. So if trend had to be continued, then what we will achieve with processors? So discussion of slow, then trends in hardware, we have that until 2004, frequency scaling or clock rate was improving CPU performance. No more automatically faster serial applications through faster CPUs. So total shift is to parallel computing in form of the multi-core processors, and how to program a 1 million core processor. It was one of the talks which we had at this group a few years ago. So here we look at the clock rate flattering sharply. Transistor count still rising, with dual core Itanium here shown by roughly 2010, and power in terms of watt more or less stabilized, and performance as per clock also not growing as fast. So transistor count increases much faster than actually achieved performance in the same time. So if we want to see live programming environment, we can go to this particular link and spend some time. So conclusions that R is comparable with other popular statistical packages such as SAS, SPSS, and STATA in terms of overall capacities. It makes it easier for others to validate research results and check for errors. Allows to develop a portable code which can be used on a variety of platforms, Windows, Linux, Unix, Mac. The latest release of the source code, such as it was when I was originally created this presentation was 2016. The patch was known as R332. It is Unix-like CPU, Linux, GNU, exists for a variety of the platforms. I mean, Unix-like in terms of the operating environments where you need to do some coding in order to make it all happening, rather than graphical user interface only. There are other compositions of distributions for Windows and Mac users may want to have precompiled packages rather than to install from scratch. Better performance of our basic system can be achieved by better education of our programmers, but not all our users are programmers. That's why it can be tricky. May require a redevelopment of our system from scratch in C, Fortran, etc., for the further improvement of performance. So you may want to make initial modeling, achieve certain results, find out that this approach will work with this kind of data, and then after that redevelop whole the system when you know what you want exactly to have in your system. Like playing platform, like on design stage for some particular system which need to be achieving high performance. References have been mentioned for those stuff, including for various graphical user interfaces, etc. And the resources can be obtained for further explorations. If you have any questions.
Yeah, you mentioned the hardware aspects. Does R out of the box take advantage of parallelization and GPUs and stuff like that, or is that something you'd have to do by interfacing to an external module that you write in C or something like that?
So in Hadoop execution of R by IBM provides programming model for massively parallel in database analytics, means that with orientation of or using of the parallel processors. Parallel R is another thing by revolution for employing of the parallel platforms.
So it's all happening through the commercial development
Yes.
rather than the open?
Yes, because they probably have more resources, and because of that create specialist packages which they want to get return from. So that's my understanding that, well, it's probably natural that if task is such a big that you need to employ massive computer, then you need professional tool.
Can I comment on this one? I mean, I think well, one of the main things that will hold back the, well, if you like, reference implementation by the R core team, that they release the new one every 6 months, I think, and well, a new one is just coming up. Is that, well, I mean, the code base in C in parts is, well, to be quite frank, I think it's rather terrible. And I mean, well, partly due to design issues, but mainly I think due to implementation issues, does not lend itself. I mean, the core engine is not properly re-entered in all these things, so therefore it's in a weird position because the language is rather nice, functional. I mean, it's awkward in some ways, but functional aspects would somehow lend themselves to parallelization, but the implementation is not conducive. And that's why I think, well, I mean, some people have picked up on this and built their own implementations that take advantage or that allow much more parallelization. But I mean, it is a somewhat weird situation, I think. The same, by the way, goes for the object orientation in R as well. I mean, I think it's not very good.
Yes?
Does R have its own spreadsheet?
Sorry?
Does R have its own spreadsheet as part of the language, or do you need to link it to a spreadsheet like Excel or
That is not what I come across, that it would be kind of interface like spreadsheet rather than there are graphical user interfaces which help you to develop our code rather than philosophy of the cells or linked cells or something like that, which is completely different philosophy. I don't know, to be honest. There are so many packages, maybe somebody experimented with that.
Well, I mean, as a general comment, I mean, if you use R, you don't want a spreadsheet because, well, one of the advantages of R, as you said, is that when you have the code separate, you can inspect that, and well, that is the nightmare of spreadsheets. That I mean, it's an inextricable mess of data and code, and you can't properly examine the code really. And I mean, let alone apply the same code to process the next load of data. And you can probably copy the spreadsheet and then fill with it, but this is where it all goes wrong. I mean, including the robot from but not only that one. Well, the other thing is that, well, I mean, in terms of interfacing to spreadsheets, well, you can. I mean, there are modules or packages to basically load data from standard formula Excel, that is to say. So you can sort of open an Excel workbook and then go to a particular sheet, and then Excel is more or less like a data frame, which is the standard table data structure in R. But I mean, that's as much as you want to have to do with the spreadsheet aspect. I mean, then you get at the data and you do the processing in R. I mean, otherwise, why would you want R?
I mean, what built-in data structures are there, or do you have, are they
What are?
data structures, or you have to do them via develop your own via object-oriented, or are they all in packages, or what? There's list trees, hash tables, all these sorts of things. Are they Python? You have lists.
That I cannot tell you because I have not written any significant code in R. Just looked at it more like as system rather than per se programming environment. Maybe I can tell a little bit more about that.
Yeah, I mean, well, I mean, since you mentioned specifically things like trees and hashes and such like, well, they in a sense do exist. Well, the main data structure, well, if you use well, sort of vanilla R, is in fact the data frame, which is like a rectangular table.
Database tables.
Yeah, you could say that. Yes, I mean, well, I mean, each column has a type, yeah, and well, each row you can think of like well as an object in certain ways. The main difference to languages like Python is that R does not have anything like references, which makes things like trees very difficult to realize. And where you can do that, I mean, you can basically, I mean, interpret the data frame well, then, I mean, as a tree. But well, I mean, that's shoehorning it. So most of the times these will be written in add-on modules in other languages. Well, I mean, that's one of the limitations of R, that where they've over the years completely abandoned the idea of having any references. I mean, it's now kind of more or less actively even discouraged. Well, I mean, that's a gut feeling. I mean, I couldn't point to where the core team do that, but well, when I started using R many years ago, there was a way to get at a reference and I mean, sort of do it if you really want, and they've done away with it more or less deliberately. I mean, that much I can remember.
Presumably you can do it using objects and define your own.
Yeah. Well, the object orientation in R is not what you might think it is if you come from languages like Python or Java. An object does not in R have a mutable state object is not the kind of object you get in R, which is partly due to the sort of functional concept that, well, I mean, I think it even comes from S, but I mean, I've never done any S, but R is quite a functional language, and the object orientation is based on that, which does
when I used R briefly about 4 years ago, I found the most useful approach was actually I was using Perl to extract all my data from various sources, build sophisticated data structures like trees and hash tables and so on, but then used Perl's module to interface with R, so I could then just throw a matrix of data at it, get R to do the statistical stuff, which was, you know, give me these correlations, give me these statistical tests, and then bring that data and the results back into Perl again, where I could then manipulate the data structures in the Perl environment. And I think I even actually I wasn't happy with some of the built-in graphics at the time with R, so I was actually using then Perl's GNU plot module to then pass the resulting data out to GNU plot to generate different types of graphics. But I imagine the R.
But they seem to be very proud of the graphic.
Well, I think that the dynamic graphics actually sounds quite interesting, but I never got into the dynamic side of the charts. I was just producing static charts for large volumes of data, sort of repeated charts for different sets of data and things like that. So
you were more or less sort of using R as a library just to do your statistics.
yeah, just a statistical crunching library. Yeah.
As a special purpose tool for that. Courses for courses kind of.
Yeah, I mean, especially because of the area I work in with musicology, I'm having to get music data from using libraries that you'd never find a library in R for pulling in music data necessarily from particular formats, but Perl has that kind of stuff, so it's just sort of getting the whole data flow. Well, that's what worked for me anyway.
Okay, that's enough probably. Thank you very much for your attention. The slides will be put on the website apsg.bcs.org. I'm sorry to see that actually I prepared in a very old version of PowerPoint and it was perfect, but now it's somehow distorted because of the modern version of PowerPoint. So I will put obviously PDF there, which will be all stabilized.